Hi, hello, I'm Sridhar. In this video, I'm going to explain about the electrolysis concept and with one example. Let us see the recap of the previous syllabus. In previous periods, we discussed about the what are the conductors and its types. Okay, that is already we discussed. What is the mean by conductor and its classification based on the mechanism of flow of electricity. That is two types: electronic conductors, electrolytic conductors. And again, we discussed about the types of electrolytes. That is, the electrolytes due to the extent of ionization that can be classified into strong electrolytes and weak electrolytes. Already we discussed about that in previous periods. And also we discussed about the behavior of electrolyte in the form of homogeneous electrolytic dissociation theory. He was given some postulates. Okay, that is the theory of the Arrhenius theory of electrolytic dissociation to explain the behavior of electrolyte. Okay, in this period, we are going to know about what is the electrolysis and what is the construction and working of electrolytic cell. And also we discussed about the process of electrolyte of the process of electrolysis of fused NaCl. Okay, in this period we are going to discuss about first what is the electrolysis, what is the construction and working of electrolytic cell, electrolysis process of fused NaCl. Now let us see the definition of electrolysis. The substances whose whose aqueous solution undergoes decomposition into ions when electric current is passed through them are known as electrolytes, and the whole process is known as electrolysis or electrolytic decomposition. Let us see here, when the passage of electric current through the electrolyte, the decomposition occurred in the electrolyte and it gives ions, and those ions are moves towards oppositely charged electrodes. Okay, this whole process is carried out in a particular cell, then that is called as electrolytic cell, and this whole process is called as electrolysis or electrolytic decomposition. Once again, I am repeating, the substances whose aqueous solution undergo the decomposition into the ions when electric current is passed through them are known as electrolytes, and the whole process is known as electrolysis or electrolytic decomposition. Next one, we discuss about the construction of electrolytic cell. Okay, the device in which the process of electrolysis or electrolytic decomposition is carried out is known as electrolytic cell or voltmeter. The device in which the process of electrolysis or electrolytic decomposition is carried out is known as electrolytic cell or electrolytic cell or voltmeter. Okay, this total setup is the voltmeter. Here the electrolysis process is carried out, then this cell is known as electrolytic cell or voltmeter. This voltmeter or electrolytic cell consists of a vessel, two electrodes and electrolytic solutions. Voltmeter convert the electrical energy into the chemical energy, that is, the electrical energy is supplied to the electrolytic solution, bring about the redox reaction, that is electrolysis, which is a non-spontaneous and takes place when electrical energy is supplied. Means voltmeter, this converts the electrical energy into the chemical energy. Okay, when the electrical energy is supplied to the electrolytic solution, that can be dissociated into ions, and then further those ions are moved towards electrodes, and then corresponding reactions are takes place at the electrodes. Okay, that is process is known as, generally this oxidation reaction is takes place at anode, reduction reactions that takes place at a cathode. Then the electrolysis process, in this electrolysis reduction reactions are takes place when only the supply of electrical energy through the electrolytic solution. In voltmeter, both the electrodes are suspended in only one electrolytic solution or melt of the electrolyte in the same vessel. Okay, let us see here the diagram. Only one electrolytic solution is taken in this vessel with those electrodes are placed in this one electrolytic solution. Okay, next, the electrodes are taken in a voltmeter, maybe of same or different materials. Okay, the electrodes are maybe same or different. Generally, the platinum electrodes are taken in the electrolysis process. During the electrolysis, in a voltmeter contains are cations are discharged on the cathode and anions are at anode. Okay, during the electrolysis, cations are discharged at cathode and anions are discharged at anode. In a voltmeter, outside the electrolyte, electrons flow from anode to cathode, and then current is flow from cathode to anode. Here the flow of electrons takes place from anode to cathode because of when the passage of electricity through this battery to the electrolytic solution, this electrolyte can be dissociated into cations and anions, and then these ions are moves towards oppositely charged ion electrodes, and cations are moved towards cathode side, anions are moved towards anode side. Whenever anions are moved towards anode side, here the oxidation reactions are takes place, means it releases the electrons. Okay, those electrons are moves from anode to cathode. Then the flow of electricity is opposite to the flow of electrons, that is cathode to anode. It is the construction of a electrolytic cell, means okay, this process is carried out in a vessel is known as voltmeter. Okay, in this it consists of one electrolyte solution and two electrodes. Here the electrical energy is converted into chemical energy by the supply of electricity. Okay, then redox reactions are occurred at the electrodes. That can be takes place in a non-spontaneous because of when the supplying of electrical energy only the reactions are takes place at the electrodes. In a voltmeter, both the electrodes are suspended in only one type of electrolytic solution in a same weather. Okay, the electrodes are may be taken same or different materials. During the electrolysis, the, in a voltmeter or electrolytic cell, cations are discharged at cathode and anions are discharged at anode. In a voltmeter, outside the electrolyte, electrons flow from anode to cathode. The current is flow from cathode to anode. Now let us see the mechanism of this electrolysis or construction of the working of the electrolysis. The net chemical change that takes place in a cell is called a cell reaction, which is a non-spontaneous in the case of electrolytic cell. In this cell, when electricity is passed through an electrolyte, in that ions move towards oppositely charged electrodes. That is, cations move towards cathode side, that is negatively charged, while anions move towards the anode side. Okay, in this cell, when electricity is passed through an electrolyte, the ions moves towards oppositely charged electrodes. That is, the cations move towards cathode side and anions are moved towards anode side. The anions on reaching the anode give up their electrons and converted into the neutral atoms. A minus, it is a anion. When it is moves to anode side, it leaves the electrons and it forms a neutral molecule. On the other hand, the cations reaching the cathode take up the electrons supplied by the battery and converted to the neutral atoms. That is P plus. When it is taking the electron, it is reduced as B. Means the oxidation reactions that takes place at anode and reduction reactions that takes place at cathode. Okay, when we take any electrolytic solution in the vessel, when we pass the electricity through this electrolytic solution through the battery, first of all the electrolyte can be dissociated into ions according to Arrhenius dissociation theory or electrolytic dissociation factor. When electricity is passed through an electrolyte, that can be splits into the positively and negatively charged ions. Okay, those ions are moves towards oppositely charged electrodes. At that stage, those ions are give up their charges by the gaining or losing the electrons. For example, if an ion is moves towards an anode side, that may leaves some electrons and it forms a neutral molecule. That is, oxidation reactions are takes place at anode. On the other hand, cations are reaching to the cathode take up the electrons supplied by the battery and converted to the neutral atoms. Okay, here it gains the when cations gains the electrons, it is reduced as a neutral molecule. That is the reduction reaction is takes place at cathode, oxidation reaction is takes place at anode. Now let us see the example of the electrolysis process. Here you can see the electrolysis of molten NaCl or fused NaCl. Okay, in the molten NaCl electrolysis, we have to take the molten NaCl as an electrolyte in electrolytic cell. Okay, when we pass the electricity through them, this molten sodium chloride, generally it contains sodium plus Cl minus ions. It is in the liquid state. This can be converted into Na plus Cl minus. On passing the electricity, sodium plus ions move towards cathode while Cl minus ions moves towards anode side. Okay, here when passing the electricity, sodium plus ions are moves towards cathode side, means it is a cation. It is moves towards cathode side. Anions are moves towards anode side. Cl minus ions are moves towards anode side. On reaching the cathode and anode, the following reactions are occur. That is, at cathode means it is a negatively charged electrode. Here it attracts the positively charged ions, that is cations. When it is gains the electrons, it is reduced as a sodium. At the same time, at anode means it is a positively charged electrode. It attracts the negatively charged ions, that is here Cl minus ions. Okay, when it is lose the one electron, it is reduced. It is converted as chlorine. Means here it is losing the electrons. Then it is oxidized. Means it gives Cl. Okay, this chlorine is a unstable in the atomic state. Again, it will be combined with the chlorine. It gives the chlorine gas. Chlorine gas. The overall reaction in this case is 2Na plus 2Cl minus gives rise to 2Na plus Cl2 gas. Okay, the sodium is obtained at the cathode. Chlorine gas is liberated at the anode. Okay, let us see this picture. Here we are taking molten NaCl, and here we have to take in two electrodes, and these two can be connected through a battery. When we pass the electricity through this here, this molten NaCl splits into Na plus Cl minus. Yet the Cl minus ions are moved towards anode side. This Na plus ions are moved towards this cathode side. Then we have to let us just now we discuss reactions at the anode and cathode. Here the sodium is deposited on the cathode. This chlorine gas is liberated from at the anode in this reaction. Okay, in this case, just now we discussed here electrolysis. What is the electrolysis? Construction and functioning of a electrolytic cell. And also we discussed about the electrolysis of the molten NaCl. Now let us see some quick question on this. For electrolysis to work, used compound should be insulator, conductor, metalloid, non-conductor. Okay, to work the electrolysis process, that should be a conductor. The right answer is B. Okay, when it is only in the conducting capacity, then it will be splits into ions. Now let us see the second question. In the electrolysis of pure ionic molten compounds, metal is formed at anode, cathode, inert electrode, base of the apparatus. Just now we discussed the electrolysis of fused NaCl. In that case, the pure metal is deposited at cathode, means that is sodium metal is deposited on the cathode. Question number 3. In the electrolytic cell, the flow of electrons is from cathode to anode in the cell in the solution. B. Cathode to anode through the external supply. C. Cathode to anode through internal supply. D. Anode to cathode through the internal supply. The right answer is D, because in electrolytic cell, cathode is acts as source of electrons, means the anode to cathode through the external supply. The flow of electrons is from cathode to anode to cathode. Just now already we discussed in the electrolysis process, when the electrons released from the anode, that can be moved to the cathode side to the external supply or internal supply. Question number 4. An electric current is passed through an aqueous solution of following, which one shall decompose? A. Urea, B. Glucose, C. Silver nitrate, D. Ethyl alcohol. Here the Right answer is silver nitrate. Remaining all are the non-electrolytes because of those who are not having any capability to split into the ions. Then the right answer is silver nitrate. It has acts as electrolyte. On ionization it produces partially Ag plus and NO3 minus ions, but remaining all the urea, glucose, ethyl alcohol does not give the any ions on electrolysis. Next one is question number 5. Pure water does not conduct the electricity because it has low boiling point, is almost totally unionized. C. It is neutral. D. Is readily decomposed. The right answer is B, because it does not have the ions. Okay, pure water it does not have any ions, means almost totally ionized. Pure water is almost means it does not conduct the electricity. Now let us see the what is the just now we discussed the process of the decomposition of an electrolyte by the passage of electric current, and also we discussed the what are the products formed in the electrolysis of molten NaCl. As we covered the electrolysis of a direct electric current through ionic solution, that is either in a molten state or in a suitable. This results when we take electrolysis of fused NaCl, when we pass the electricity in that case, sodium ions are migrates to the cathode side and it is reduced as a sodium metal. Chloride ions are also moved to the anode side, give up their electrons at the anode and are oxidized to the chlorine gas. This is the aqueous electrolysis of aqueous NaCl solution. What happens when we have this taken? In last class we discussed the electrolysis of fused NaCl. In that case, when we pass the electricity through them, the fused NaCl splits into the Na plus and Cl minus ions. Na plus and Cl minus ions. These Na plus ions are moved towards cathode side and it produces the sodium metal on the surface of cathode. And next one is the chloride ions are moved towards anode side and it gives the chlorine gas at the anode. Now let us see the electrolysis of aqueous NaCl solution. Okay, in this kind of experiment is observed in the Nelson cell. Okay, here aqueous solution of NaCl is taken as an electrolyte in the cell. What happens when we have an aqueous solution of sodium chloride? We cannot forget we have to the factor the water into the equation. This water can be oxidized into the H plus and OH minus ions. At the same time, the NaCl also splits into the Na plus and Cl minus ions. Na plus and Cl minus ions. Here we have to see the reaction is in this kind of aqueous sodium chloride electrolysis process. At anode, Cl minus ions are oxidizes to the chloride. At the same time, H2O molecules gives the oxygen plus hydrogen ions. At the same time, it gives the Cl minus ions gives the Cl2 gas. The ion selective membranes allows the counter ion of Na plus to freely flow across, but anions such as hydroxide and chlorine gas are diffusing across. At cathode, H2O molecules gains the electrons and it gives the hydrogen gas plus 2OH minus ions. The net process of reaction is here in this is simply we can observe in this it is NaCl aqueous NaCl solution. It produces a Na plus, Cl minus, H plus and OH minus ions. Okay, Na plus ions are moved towards Na plus ions are combined with the hydroxyl ions which are present in the water and it produces NaOH molecules. The Cl minus ions are moved towards anode side and it gives the Cl2 gas. The hydrogen ions are moved towards anode side and it give up the hydrogen gas. The sodium metal and chlorine gas is getting in the case of molten electrolysis of molten NaCl. In the case of electrolysis of aqueous NaCl solution, it produces the hydrogen and chlorine gas. Now let us see some which questions on this is what is the name given to the solution being electrolyzed? Salt solution, electrolytic solution, mineral solution, electrolyte. The right answer is electrolyte. Okay, next one is when NaCl solution is electrolyzed, what happens? What has forms at the anode? Hydrogen, oxygen, chlorine, and sodium. Okay, when NaCl solution state at anode, it forms the chlorine gas. Just now we discussed. What is the equation to the show when happens to the Cl ions at the anode? Cl minus ions combined with and it forms the chlorine gas with the liberation of 2 electrons. The right answer is B. What is the addition of oxygen to a substance called decomposition, reduction, oxidation, extraction? Addition of oxygen called here oxidation. Now let us see the frequently asked questions in this is what is the electrolysis? Write the construction and functioning of a electrolytic cell. Sometimes they may ask as a question what explain the electrolysis of fused NaCl. Sometimes they may ask as a question explain the electrolysis of aqueous NaCl solution. Once again I am repeating the total topic of this is the construction of the electrolytic cell, a device in which the process of electrolysis or electrolytic decomposition is carried out is known as electrolytic cell or voltmeter. Okay, this voltmeter consists of a vessel, two electrodes, and electrolytic solution. Voltmeter convert the electrical energy into the chemical energy. That is, the electrical energy is supplied to the electrolytic solution to bring about the redox reaction, which is a non-spontaneous and takes place only when electrical energy is supplied. Okay, in a voltmeter, both the electrodes are suspended in only one of the electrolytic solution or melt off the electrolyte in the same weather. Okay, here the electrolyte is taken only one. In that electrolyte we may take two same type or different types of electrodes. Okay, during the electrolysis in a voltmeter, cations are discharged on the cathode and anions on the anode. In a voltmeter, outside the electrolyte, electrons flow from anode to cathode, but its current is flow from cathode to anode. Okay, simply here the electrolysis process is carried out in a vessel is known as electrolytic cell or voltmeter. Here we have to take one type of electrolytic solution. In the solution state, we have to place the two different electrodes or same type of electrodes are placed in a electrolytic solution, which are acts as anode and cathode. Okay, these two electrodes, when it is connected to the battery, one is acts as anode and another is acts as cathode. Here the electrolytic cell, the electrons are flow from anode to cathode, but current is flow from cathode to anode. And now let us see some functioning of this electrolytic lysis process. The net chemical change that takes place in the cell is called a cell reaction, which is a non-spontaneous in the case of electrolytic cell. In the cell, when electricity is passed through the electrolyte, the ions move towards oppositely charged electrodes, that is the cations move towards cathode and anions move towards anode side. Means the oxidation reaction takes place at anode, reduction takes place at cathode. In the case of fused NaCl solution, then fused NaCl solution is taken into a electrolytic cell. When we pass the electricity, first the NaCl is splits into the Na plus Cl minus ions. Okay, these ions are moved towards oppositely charged electrons. Here the Cl minus ions are moved towards anode side. Na plus ions are moved towards cathode side. Means sodium metal is formed at the cathode, Cl2 gas is liberated at the anode. Is in the case of molten NaCl solution. But in the case of aqueous NaCl solution. In the case of aqueous NaCl solution, first the aqueous NaCl solution consists of NaCl H2O molecule. First, when we supplying the electricity, the aqueous NaCl solution splits into the Na plus Cl minus ion, H plus and OH minus ions. Na plus and Cl minus ions are Na plus and OH minus are combined to form the sodium hydroxide. The remaining Cl minus ions are moved towards anode side and it liberates the chlorine gas. The hydrogen ions are moved towards cathode side and it liberates the hydrogen gas. Okay, simply we can observe in this concept, electrolysis concept. In the case of electrolysis of molten NaCl, sodium and sodium and chlorine gases are formed. In the case of aqueous sodium chloride, it forms the hydrogen and chlorine gas at the electrodes. Okay, mostly the asked questions in this topic is what is the electrolysis, what is the construction of electrolytic cell and its functioning. Sometimes they may ask as a question, explain the electrolysis process with one example. And next one is, it may ask as what is the electrolytic what is the electrolysis of, explain the electrolysis of aqueous NaCl solution. Okay, these are the main topics in this period. They may ask as a question from here. Thank you.